Well, hey guys, in previous videos we've been talking about the idea that money can have some value in the future. Like it can go up in value if you put your interest earned back into your bank account and it compounds. And we've talked about compound interest and the fact that money can have some value in the future. But what about things that aren't money? What about the things that we buy? It might be groceries, it might be cars, just our normal living expenses. Because obviously 20 years ago, you've heard people say stories of, oh, yeah, it only cost me, 50 cents for a can of Coke. Well, it costs a lot more now because things over time cost more to buy. And we call that inflation. But there's another way that things can go up in value and have some greater value in the future. You might know someone who has a historical car or a rare car. Things that are rare will often go up in value. Maybe people who buy art as an investment, knowing that in years to come it may go up in value. I'm quite into guitars, so I know there's a lot of very rare and expensive guitars that over time have gone up in value because of their unique nature. Well, we call this appreciation. So when something goes up in value, it appreciates. So we've got inflation and appreciation. Now, both of these relate to things rather than money, but we can still work out some increased future value. And those words, future value, should sound familiar because we have a formula that we've been using for future value, which is effectively our compound interest formula. Okay, so I'm not going to go through all of these because we've covered them in previous videos. But if we have a quick look, the future value is what it's worth in the future. PV is the present value. R is the rate that things increase, and N is the number of time periods. So we can use that to apply to inflation and appreciation questions. They work just like compound interest questions. So let's have a look. What's the price of a $1,200 lounge in 5 years if inflation is 3.1%, PA, which stands for per annum? So this is a yearly increase of 3.1% over 5 years. So we can simply apply our future value formula to this inflation question. Okay, we've got a, let's have a look. What's our PV? Our present value of the lounge is 1,200. The number of time periods, well, it's going to be every year for 5 years. So N is 5. Now remember when we use the R, the rate, we're not using 3.1%. We're dividing that by 100 because we always want to use the decimal version. So in this case, if I divide that by 100, I get 0.031. Now it's just a case of sticking those values into the formula to get this. Whack that into your calculator and you'll get a future value of $13.97.90. Due to inflation, that lounge will be dearer. It'll have a future value of this amount. Now what about an appreciation type question? A rare guitar is currently valued at $20,000. What will it be worth in 10 years if it appreciates at 2% per annum? And round that off to the nearest 100. Okay, it's an appreciation. It's a future value question. So we're going to use our formula. In this case, our present value, what it's worth today, is $20,000. The number of time periods is 10. So over 10 years, because we're doing it per annum. So every year for 10 years. It'll go up, and the rate, once again, divide that by 100 to get the decimal value of 0.002. Pop it into the formula, whack it into the calculator, you'll get this amount, but don't forget to read the full question. It says round this off to the nearest 100. So looking at my hundreds column, which is here, I go to the next digit. Is that 5 or more? Yes. So I round this from a 3 up to a 4 to get $24,400 for that rare guitar in 10 years time if it only goes up by 2% per annum. Good job, well done.